In chapter 3, we are going to be looking at parallel lines, and we're going to start today by defining a lot of terms. If we're going to talk about parallel, that would be a good thing to start by defining first. So parallel lines, we have a symbol of just two little lines right next to each other. So the symbol looks like two little parallel lines. The definition of parallel has two key parts to it. Parallel lines are coplanar lines. That means they are in the same plane and they don't intersect. Okay? They are in the same plane and they don't intersect. The reason why it's important that we include both of those characteristics is because skew lines are also lines that never intersect, but they are non-coplanar lines. Okay? So parallel lines I could draw on a sheet of paper and they're just going to run along side by side. But skew lines I could not draw on a sheet of paper. So then we're thinking like in space, two lines that are heading at different angles, they're not going to hit each other, but there's no way to contain them in a plane. Parallel planes are planes that don't intersect. If I have a parallel line in a plane, it's a line in a plane and they don't intersect each other. But when we define parallel and skew, we need to think about that characteristic of either being in the same plane or not being in the same plane. Theorem 3.1 says that if I have two parallel planes and a third plane cuts on through those, that the lines of intersection are going to be parallel. I'm not going to take the time to have us write out the full proof here, but we'll talk about what that proof would look like. So if I wanted to prove that I had parallel lines, I need to consider both parts of the definition of parallel. So the first part of the definition of parallel is that they are in the same plane. So I know from this picture that L and N are in the same plane because what plane are they both in? Z. Okay? So they are coplanar. The next important thing to say, if I'm trying to prove that they're parallel, is that they don't intersect. So parallel lines are coplanar. They have to be in the same plane. They are both in plane Z. And they need to not intersect each other. So how would I be guaranteed that those two lines are not going to intersect each other? What do I know about planes X and Y? They're parallel. So if I have two sheets of paper and I draw lines on those papers, if the papers are not touching each other, is there any way the lines are going to touch each other?
No.
No. Okay. So that means those two lines, L and N, will have to be parallel. They're in the same plane, and there's no way they're ever going to hit each other because the planes that they're in don't hit each other. Some more terms. A transversal is a line that intersects two or more coplanar lines at different points. So our kind of standard pictures, I've got two lines. They could be parallel, not parallel, but two lines that are in a plane. And I have a third line that's going to come across through there. That third line is called the transversal. When this happens, we get some special angle pairs. The first one is called alternate interior angles. I'm big on abbreviations. We're going to be talking about these things a lot. I call them AIAs.
Nice.
Okay, alternate interior angles. Alternate interior angles are defined as being not adjacent to each other, so they should not be right next to each other. They need to be interior, which means on the inside of the set of lines. And they need to be on opposite sides of the transversal. So when we have a picture like this, we created a lot of angles here. So locating some AIAs in here, alternate interior, I need them to not be right next to each other. I need them to be inside of the pair of lines. And I need them to be on opposite sides of that line that's cutting across. So one example would be angle 3 and angle 6. 3 and 6 are not right next to each other. They're on opposite sides, and they're in the middle of those two lines. And then what would be another example like 3 and 6?
5 and 4.
5 and 4. Okay? They're still inside of the pair of lines, so they're interior, opposite sides, and not right next to each other.
So So 7 and 2 wouldn't work because they're outside.
7 and 2 would actually be called alternate exterior angles, which we're not defining today. But since they're outside, we would call them exterior, but they are still on opposite sides. Our next special angle pair here are called same side interior angles. I call them SSIA. Same side interior angles. They are two interior angles, so again we're talking about the angles in the middle of the lines on the same side of the line that cuts across. So 6 and 4 would be a pair. And 5 and 3 would be another pair. Our third special angle pair are called corresponding angles, or I call them CAs. They are two angles in corresponding positions relative to the two lines. Okay, so English we learned when we define something, we're not supposed to actually use that word in the definition because we didn't get any new information here. So I don't know why the book gave this definition. I think it's horrible because it doesn't actually tell us where to look for these things. The way I think of corresponding angles is that they should be in the same corner position. So I want to look for two angles that are like both upper left-hand corners. So that would be like 1 and 5. Or 2 and 6 would both be upper rights. Or 3 and 7 would be lower lefts. Or 4 and 8 would be lower rights. So we're looking for a pair of angles that's in the same corner position. Questions on how to locate any of these special angle pairs? Okay, so that's what our next type of problem is going to do. We have the option of saying that each pair of angles is either alternate interior, AIA, same side interior, SSIA, or corresponding, or that it isn't actually any of those special pairs. To be one of those special angle pairs, we need to redraw our picture using just 3 lines. If I have to redraw all 4 lines, it is not a special angle pair for us. Okay? Special angle pairs exist when we have one pair of lines crossed by one transversal. So what I do is I retrace the angles in the picture and see if I end up just drawing out 3 lines. If I do it, then it can be one of these special ones. So the first one says angle 7, so I'm going to trace that out. And angle 11. So I'll trace out angle 11. I only trace 3 lines, so that means these can be a special angle pair. If I have to trace all 4, then it's going to be none. 7 and 11 then are what type of special angle pair?
SSIA.
SSIA. They are on the same side of the crossing line, and they are between the pair of lines.
Is this what we're going to see in our homework?
So some of your homework problems will be like this, identifying the angles. Your picture will look different, but same type of idea. So then for the next one, I want to trace out angle 14 and angle 16. I was able to get 14 and 16 just drawing in 3 lines, so these can be a special angle pair. What kind are they? Corresponding. They're in the same corner. They are both lower right-hand corners. Four and 10, if I trace out angle 4 and angle 10, I had to trace all 4 lines. That's not allowed. So these are none. A lot of students want to say 4 and 10 are corresponding because they are both upper right-hand corners, but there's too many lines in the picture. Our special angle pairs only exist if we're working with one pair of lines crossed by one transversal. 3 lines is all we're allowed in our picture to name a special angle pair. So since I had to trace all 4, it's no good. 4 and 2 we could do. So the next one, 3 and 6. If I trace out 3 and 6. I only had to trace out 3 lines, so that's good. And what kind of angle pair are 3 and 6 then? Alternate interior. They're on opposite sides, and they're between the set of lines. Questions? Go ahead and try the next 4.
Nice.
A couple of announcements for you here while you're working on this. If you are doing honors, you need to check in with me by Friday to let me know the status of your project. Some progress should have been made. This isn't the type of thing we wait until the night before because it's a quarter project. So some progress should have been made, and then you need to let me know if things are sticking along with your proposal. So you said you were going to do a paper, still planning on it, or I think actually I'm going to do a PowerPoint instead, or something needed to change about your topic. So just by Friday is very informal. You just need to check in with me and let me know I have made some progress and things are going fine, or I kind of hit a roadblock or I want to change something. And then the project itself is due towards the end of October. I think it's about 3 weeks away. Also, this week marks the middle of the quarter, which means that progress reports will be sent home on Friday. So if you want your grade to be different than what it is now, before those progress reports get sent home, you need to do whatever it takes to do that. So if you're missing homework, get the missing homework in. If you want to do test corrections, get your test corrections in. Those need to be done ideally by Wednesday to give me enough time to get them graded by Friday. If you get them to me by Thursday, hopefully I can do it. I do have an event Thursday night, but hopefully I will still have time to get those in for Friday morning. But if you definitely want to be guaranteed, then Wednesday should be your goal. I'll still put them in if I get them in later than that. They just won't make it in time for your progress report necessarily, but it'll still make it for your report card. Okay, so 6 and 11. If I trace out 6 and 11, I end up with these 2 lines and those 2 lines. So that's too much, and we get none on those. For 2 and 10, if I trace out 2 and 10, I only had to trace 3 lines out. So then I look at where they are. They are in the same corner position. So those would be corresponding angles. They are on the same side, but they are not interior. If we look at the set of lines, interior should happen between those 2 lines, and 2 is happening outside. So those are corresponding angles. 2 and 3, if I trace those out, I only had to trace 3 lines. I didn't need the bottom line at all. So then I look at 2 and 3. They are on the same side, and they are between the set of lines. So those are SSIAs. And 7 and 12, if I trace those out, 7 and 12, I didn't need the line over on the left at all, so those can be a special pair, and they are AIAs. They are on opposite sides, and they are between the set of lines. On your homework, your diagram is going to be a bit more confusing I think it looks something like this-ish. I don't know exactly. But what I would urge you to do is to redraw only the angles that are in the question, and then some of these lines will disappear and it won't look as confusing. It should, if it's possible to name one of these special angle pairs, it should be able to reduce down to a drawing that would just have 2 lines and 1 line crossing it. Okay? So I would urge you to kind of, in the margin of your paper, wherever you do your work, redraw the angles in the question, and that should allow you to ignore some of the lines. Okay? Questions? In these, we want to classify each pair of lines as intersecting, and that's not necessarily like they intersect in this picture, but thinking of lines as lines being going on forever, they would eventually intersect. Or are they parallel, or are they skew? Remember, parallel means 2 things. They don't intersect and they're in the same plane. Skew is they don't intersect and they are in different planes. So if I trace out AB and EJ, will those intersect? They will not. So then are they in the same plane?
Yes.
Yes, they're in the same wall, and a wall is like a plane. So those 2 lines are parallel. You can write parallel, or that's our symbol for parallel. It's just 2 little lines. The next one says AB and FK. Will those intersect? No. Now, are they in the same plane, or could they be in the same plane? Remember when we look at a picture, even if it's not drawn there, but I could draw it, then it counts. So I have to think about this thing as being like a barn. And could I take like a piece of plywood and lean it up against the wall of the barn and have it hit those lines?
See.
So I could get a plane that looks like this and connects it all, so those are parallel. So parallel is they don't intersect and they are in a plane. I could draw a plane that contains them. AB and ID. Will they intersect? No. They're on opposite sides. They're not going to come together. Could I take a piece of plywood and have it lay on the bottom of that one side and a vertical wall on another side? No. I can't take a piece of plywood and have it be both horizontal and vertical. It doesn't twist that way. So those would then be skew. There's no way to connect those lines with a straight plane.
There's no symbol for skew.
There's no symbol for skew.
Oh.
Or values.
It's a short word, so we're all right. EF and IH. Will they intersect?
Yeah.
Yes, eventually they will. Remember, lines go on forever, so these are angling in towards each other. They're both on the front of the barn, so eventually they will intersect. There's no symbol for that either.
Can we just draw the intersects? Symbol?
There is not a symbol for intersecting.
They're not like the little.
Just draw an
Can you
X.
draw it? Yeah.
Forward.
I suppose.
Oh, that's perfect.
EF and NM. Will those intersect?
No.
No.
They're angling towards each other, but one's on the front of the barn and one's in the back of the barn.
That's not
So it's probably not going to come together then. Could I take a straight piece of plywood and connect them at the angles that they are at?
No.
I could not.
It'd be hard.
Not a straight piece of plywood.
It would just go back.
Not because they're angling. On the bottom, so like in the square part of the barn, I could do like EA and NC because they're at the same angle, but these ones are heading in at different angles, so I can't connect them. And the last one, CN and FG. Will they intersect? No, one's in the front, one's in the back. Can I draw a plane? No, they're at different angles, so those are skew. Questions? Always, sometimes, never questions. There will be a portion of these on your homework. Be careful with always, sometimes, never. A lot of times we think of one way and then we assume if it works, it will always work. Or if we think of one way that didn't work, we assume it will never work. So always try to think about more possibilities. So it worked this way, does it have to always work that way? Sometimes thinking about what definitions say can be helpful to us as well. Two skew lines are blank parallel. What does it mean to be skew?
Non-intersecting.
It means they don't intersect and they're not in the same plane. What does it mean to be parallel?
Same thing.
They're in the same plane and they don't intersect. So can two lines be in the same plane and not in the same plane?
No.
No, that's not possible. So this is never because of their definitions. Again, sorry about the horrible handwriting today.
It was actually pretty good overall.
I didn't even notice the difference.
Stop. Okay, I know I always have bad handwriting. Two parallel lines are blank coplanar. What does it mean to be parallel? What does it mean to be parallel?
Never touch it.
They don't intersect and they're in the same plane, so two parallel lines are blank coplanar? Always. A lot of times thinking of a visual model using ceilings and floors and walls and sheets of paper and pencils and pens and painted lines can help us think about these situations. So in your homework, I'm going to encourage you to grab like 3 or 4 pencils, whatever it's talking about, however many lines it's talking about, and kind of twist them around and say, does this work or doesn't work? Grab some sheets of paper and say, does this work, does it not work when you're talking about multiple planes? And try it out. A lot of times visual models can make a lot more sense once we actually start playing with them and moving them around, more than just thinking in our heads. So the next one says, a line in the plane of the ceiling and a line in the plane of the floor are blank parallel. Well, to be parallel, they have to be in the same plane and they have to not intersect each other. So if it's in the ceiling and the floor, they're not going to intersect each other. Could they be in the same plane though?
Yeah.
They could. So if I drew a line straight down the middle of the room on the ceiling and straight down the middle of the room on the floor right underneath it, I could put in like a little dividing wall there, right? So that's possible, but that doesn't have to happen. If I did the lines in any other direction, that wouldn't work. So this is sometimes. Two lines in the plane of the floor are blank skew. So what does it mean to be skew? Different planes. So if I'm putting them both on the floor, could they be in different planes?
No.
No. So this is never. It's not possible. If they're both in the floor, they're in the same plane. So they could at most be parallel, but they couldn't be skew. A line in the plane of the wall and a line in the plane of the floor are blank parallel. So if I paint a line on the wall and I paint a line on the floor, could I do so in such a way that they would be in the same plane?
No.
Nope.
Yeah.
Yeah, sometimes.
What would it look like to be successful with that?
Triangle.
If you
Where the planes
the
intersect.
two lines wouldn't be in the same plane. They intersect each other, but that wouldn't make them in the same plane. If we want to be parallel, they should not be intersecting each other. So what would it look like for a line on the wall and a line on the floor to be in the same plane?
They would have to be the edges of the plane.
Okay, so it could be right at the
Good call,
crease
man.
of the
Good call.
floor. That would actually be in both of them, so that would work. Or I could do one horizontally on the wall and one kind of in the same direction on the floor and lean a piece of plywood up against it. Right, and just kind of cut off the corner of the room that way. So there are a couple of different ways to make it work, but we had to be specific about that. So that's going to be a sometimes. Could they intersect each other? Yeah, I painted one vertically on the wall and then kind of heading in towards on the floor. They could intersect each other, but again, that's very specific. Could they be skew? Yeah, so I've got a wall and a floor. They're different planes, and if I draw them in such a way that they're not going to intersect each other and I can't lean plywood up against it, then they would be skew. Again, on your homework for these types of questions, I would strongly urge you to grab a pile of pens and pencils, grab a pile of sheets of paper, and play with them. Play with models. Look at the corners of your room, whatever room you're sitting in to do your homework, and really think about visually actually making something, doing something, more than trying to hold it all in your head. Because a lot of times we miss opportunities that way.
What time do we get out?
Your homework is in section 3-1 tonight, and that is due tomorrow.